Hello students, welcome to my math lab. Today we discuss about the trigonometry chapter, SSC 10th class state syllabus, max topic, the trigonometry. Before we start the trigonometry chapter, let us discuss what does the name trigonometry actually mean. So here the word tri stands for 3 and the gono stands for angle and the metry stands for measurement. So it's basically a concept of three angle measurement. So when you discuss about a three angle measurement, the first thing that hits your mind is a triangle. So for the trigonometry chapter, we use a special triangle, which is right angle triangle. So the condition for the right angle triangle is one of the angle must be 90 degrees. One of the angle must be 90 degrees. So we name this sides. So in the lower classes, we generally name this side as the standing line, this as the slant line, and this one as the sleeping line. And uh, and these names are changed to opposite side, adjacent side, and the last one is hypotenuse. So basically, in a triangle, the line which is opposite to the 90 degrees angle is considered as hypotenuse. Always remember the line which is opposite to the 90 degrees is always considered as hypotenuse, whereas this is 90 degrees. So this line would be hypotenuse, and if the angle is given here, the line which is opposite to this angle would be considered as opposite side, and the rest of the other side is considered as adjacent side. And what if the 90 degrees is here? This would be hypotenuse, and if the angle is given here, so the line which is opposite to this angle will be considered as opposite side, and the other one is considered as adjacent side. I hope you're clear on this. So the trigonometry, the pi stands for 3 and the gono stands for angle and the metry stands for measurement. So basically the trigonometry is all about the three angles measurement. So we use a special type of triangle, the only triangle that we use in trigonometry chapter as well as the applications of trigonometry, which is right angle triangle, and the condition for it, it has to be 90 degrees, and we call these lines in the pre-primary classes as the standing line, sleeping line, and the slant line. So these namings would be changed, and we would name them as opposite side, adjacent side, and hypotenuse. So before naming them, we need to follow some set of instructions to name them. So in the right angle triangle, the side, the line side, the side which is opposite to the 90 degrees is always considered as hypotenuse. And we have other two angles. Depending upon the two angles, we name the opposite side and the adjacent side. If in case the angle is here, the, the line which is opposite to this angle is considered as opposite side and the other one is considered as adjacent side. And if the angle is given here, so the opposite line to the angle would be this. So we name this as the opposite side and the other line as adjacent side, and we know that the angle which is the line which is opposite to the 90 degrees is hypotenuse. So these are the basic things about the trigonometry. So we have some set of trigonometric ratios. Sorry. We name them as sin theta, cos theta, tan theta, cot theta, secant theta, cosecant theta. So basically, the sin theta is the reverse of the cosecant theta, and the cos theta is the reverse of secant theta, and tan theta is the reverse of cot theta. Here, the theta stands for the angle. So, if you can able to memorize these two trigonometric side ratios formulas, then you can build up the other remaining trigonometric ratios. So suppose the sine theta has the sides formula as the opposite side divided by hypotenuse, and the cos theta has a formula of adjacent divided by hypotenuse. So if you can remember these two trigonometric ratios, you can uh, build up the other trigonometric ratios. So suppose tan theta can be written as sin theta upon cos theta. So you have the formula for the sin theta as opposite by hypotenuse and the cos theta as adjacent by hypotenuse. Here you can see the hypotenuse is common in both the formulas, so you can ignore them and you can write it directly as tan theta equals opposite upon adjacent side. In the similar way, here I have mentioned that tan theta and cot theta are reciprocal to each other. So we can write cot theta as 1 by tan theta, which is reverse of cot theta. So you can write cot theta as, you have the formula for the tan theta as opposite by adjacent. You can write the cot theta formula as adjacent divided by opposite side. Now you have the rest of formulas like the secant theta. Secant theta is reciprocal to cos theta. You have the formula for the cos theta as adjacent by hypotenuse, so you can write it as hypotenuse divided by adjacent. And for the cosecant theta, it's the reciprocal of sin theta. So you have the formula for the sin theta as opposite divided by hypotenuse, and you can write it as hypotenuse divided by opposite side. So these are the few of the these are the trigonometric sides formulas in the chapter. So the main thing is that you should be able to remember the two formulas, which is sin theta and the cos theta. The side ratio formula for the sin theta is opposite upon hypotenuse, and for the cos theta it is adjacent by hypotenuse. If you can remember these two sides formulas, you can build up the other formulas, like you can see the tan theta as sin theta divided by cos theta. So tan theta equals to opposite by adjacent, and the secant theta is the reciprocal of cos theta. You can just write in the reverse order, hypotenuse by adjacent, and for the cosecant theta, it's the reciprocal of sin theta. You can just reverse them and write them as hypotenuse divided by opposite side. So these are the sides formulas that you need to remember to solve basically the first exercise of the trigonometry. And you have another thing called Pythagoras theorem. So the questions would be, he would be giving any two sides values, and he will ask you to find out the value of the third side. For this we use trigonometry, we use the Pythagoras theorem to solve it. For suppose consider it as A, and this as B, and this as C, and let us consider the angles here. So hypotenuse would be the one which is opposite to the 90 degrees angle as the hypotenuse, and the one which is opposite to this angle is AB, so this would be the opposite side, and the other one would be adjacent side. So the Pythagoras theorem states that hypotenuse square is equals to opposite square plus adjacent square. As of now, please remember the formula, and once we discuss the similar triangles topic, I will let you know how does this formula has been derived. So for the Pythagoras theorem, the formula would be hypotenuse square equals to opposite square plus adjacent square. Let us take an example. Yes, give me a minute please. Okay, first suppose there is a triangle ABC. Here it is given as 90 degrees and it has given two values 3 and 4, and this is the angle. Now he is asking us to find this with also. So the value of AB is 3 and the value of BC is equals to 4, and is asking us to find AC. So the one which is opposite to this 90 degrees angle is hypotenuse, and the one which is opposite to this angle is opposite, and the rest other is adjacent. So here we use the Pythagoras theorem. Pythagoras theorem states that hypotenuse square is equals to opposite square plus adjacent square. So here the hypotenuse is AC square and the opposite is AB square and the adjacent is BC square. So we don't know the AC value, so we substitute in AB 3 square plus BC as 4 whole square. So AC square equals to 9 plus 16. So AC equals the square root. The square becomes square root 9 plus 16 is 25, and AC is equals to 5. AC is equals to 5. So what is the value of the hypotenuse here? It is 5. And this is how you find the missing side value using the Pythagoras theorem. And this will be the end of this particular video session. I hope you like it. Please do like and share it and subscribe it, and we will start the first exercise in the next video. And if you have any doubts, you can message me.